So this one says U.S. college enrollment has grown from 14.3 million in 95 when I graduated to 17.4 million in 2005. Calculate the U.S. college enrollment for 2002. Okay, gotcha. So for each of these problems, it tells you the little italics in the top and the middle of page 214 to first figure out the equation. Once you have the equation of the line, you can make predictions for later. Now, there are a lot of things in real life that looks like it might be a straight line, and it turns out it's not. So, I mean, people very quickly determine that the stock market is a really bad one to make any predictions about. Because, yeah, it's going, let me put all the money into it. Oh, shit. So it can quickly become not linear. But something like watching a baby deer grow or something, you're pretty certain it's going to follow a pretty solid. As it gets older, it's going to get bigger up to a certain point. Thankfully, it doesn't become the 50-foot deer. It takes over Manhattan or something. This one says, assuming that it's going to continue on that linear growth. So it's 14.3 million in 1995. This is the right one, right? Thank God. And it's 17.4 million in 2005. And whenever I have dates like this, I pretty much call this one 0. Do you have to? No. I don't know if anybody did. Bless you. Did anybody do that possibly? I don't know if everybody's gotten up to this point, by the way. This might be a little preview for some of us. Let's do it this way. Let's just do it calling these exactly what they are. For the equation of a line, what two things do I need?
Point.
I need a point,
Slope.
and I need the slope. Well, I've definitely got a point. In fact, when they give you information like this, you might want to go ahead and put it like a point. How would this look as a point?
0.
What do you think would come first? Now let's go ahead and get away from 0. Let's call it 1995. Why not?
So 1995, then 14.3.
Yeah, 1995, comma, 14.3 million. Let's all agree to leave the million off and we'll just know it's in millions. Is that cool? Yeah. Let's not put all those zeros in there. And this is 2005, comma, 17.4. Let me go ahead and force it into, like I said. Yeah, here we go. Because they do that in the book. You guys see how this might make the numbers become rather disgusting? You can see how that might happen. So let me instead call this 0, 14.3. So if I call that the 0 time, what's this going to be? 10. Now that looks a lot more manageable. Right, I can make that scale easier. I can graph that easier. My slope's not going to have freaky ass numbers in it.
Just because it's 10 years later?
Yeah, just because it's 10 years later. What's really important here is how far past 1995 I've gone. So the point, which one is a really good point to use?
0.
This guy, because what is it actually?
The y.
Y-intercept, which means I got a much easier way of doing this. And how do I get the slope?
Times of this, right? I mean,
I've got 2 points. How do I always get the slope when I have 2 points?
oh, y2.
Yeah, y2 minus y1. So it'll be 17.4 minus 14.3 over 10 minus 0. Now you're going to come out with something that you would never really want to graph by hand. Thankfully, this question says nothing about graphing it. It just says something about using it. It's an equation. I can plug stuff in and get stuff out, like any equation. So what do I get here? 3.1 over 10. Divided by 10 makes a decimal. Go back 1, so 0.31. Now I know this is in the point slope section, but let's be smart. I have a very special point. So I don't have to use the y minus y1 equals mx minus x1, do I? Please tell me I don't have to. Because what's this going to be? This is m. This is
Y.
Y?
Just the y-axis.
b.
Y,
Oh,
oh.
B.
So y equals mx plus b. Y equals 0.31x plus
14.3.
14.3. Good. All right, so this is really nifty. I mean, this is actually, we're sort of doing some very basic statistics. We've made some observations. We've seen what's happened over time. And we're going to use that information to make predictions. That's exactly what statistics does. This is still algebra, but statistics uses algebra all the time. So now that we have an equation based off of what we've seen, I can plug in other stuff that I haven't seen and make predictions about it. So what's this actually asks? Part A says, calculate the enrollment for 2002. And our x variable, remember, is really the time. Our x variable is the time. What am I going to plug in for that for 2002? What's the beginning year? 95. So what's 2002 going to be? 7. Yes, sir.
So you just do 7 times 0.31.
Yep, just plug it in. So y equals 0.31 times 7 plus 14.3. In the middle of a problem, if you ever forget what x represents, what y represents, just go back to the points you made. This was the time, this was the number of students in millions. So what's going to come popping out of here? What do you guys get when you do that? 16.47? And what does that mean?
That's the enrollment growth.
It's not growth. It's exactly when it's 2002. 7 years after 95, there.
1.7 million enrollment.
Yeah, 64.47 million people enroll in college, right?
Oh, people. Oh.
And then it says, is everybody with me there? I mean, this is really kind of nifty. So, given some observations, we create an equation. Doing the steps we already know is true. I know how to find the slope. Thankfully, one point I had was the y-intercept, so I could use the easier equation. Once I have that equation, I could use it now to answer all these questions in this situation. They could say 2002, put a 7 in. 2010. What am I going to put in for the input? Yeah, it's going to be 15 years after 1995, right? Where it was. So now I just plug a 15 in there and see what happens. Now, we get almost 19, so.
18.95.
So y equals 18.95. So, just to show you the work, you plug in, you got your 0.31, plug in your 15, and it tells you out comes the number of students, 18, what was it?
18.95.
95 billion, blah, blah, blah. How do you guys feel about that? Yes?
I have a question. If we can do like between 0 and 10, but we just use like the date 1995.
Yes. Okay. You can do that. You would have gotten different slopes and stuff, but I mean, when you plug in, you would have plugged in the whole number 2002. You should still get the same number out. Yeah. Just because I choose to use this format or that format shouldn't change the number of students in that year. Yeah. Cool. So remember the basic idea is we focused a lot the other day on, in these situations, how do I find the equation of a line? So I said when we're parallel to this line and we go through this point, we use the same slope. At the point we plug it in, we go to town, right? We might have to use this guy. Right? Does that sound familiar? Maybe that's a good place to start with some review. Get that sense. So let's do one that's just about finding the equation of a line, and then we'll take it a little bit further. So everybody got what they want here? Yeah.
What if you didn't have the y instead?
Then you would have used this.
Okay, so
Yeah.
the y equals that would be only y.
Yeah. There is a way to use that indirectly, but I'm not going to show that one, just to keep things a little less confused, a little more clear. Okay. So let's do this. Let's do this kind of thing. Let's say 1 year after I bought my first car, let's say it was worth, what would it have been, Jeff? I don't know. Let's say it was worth $13,500. And then let's say 3 years after I bought it, it was worth $9,850. And then I want to know, okay, 10 years from now, what's going to work? So let's just focus first on creating the equation that represents this situation. So I've made 2 observations. So from those 2 observations, I'm going to make this equation of a line. Okay. Now, on another level, does everything in the world follow a straight line? No. So, but we're not quite at the point where we can use the mathematics to help me create stuff that might actually follow things a little bit better. But a lot of things are really pretty close to a straight line, to tell you honestly. That gets you through a decent amount of problems, is just looking at the line. So what 2 points do I already have up here?
1.
Yeah, 1 year later, 13,500. 3 years later, 9,850. It's a really good idea when you write points and you have large numbers to stay away from using commas, because then you forget where the first point ends and the other one begins sometimes, so be careful about that. So what 2 things do I need for the equation of the line? Need a point, need a slope. Do we have the magic nifty point here? No, we just got 2 everyday ordinary points. Crap, so pick one.
13,500.
So I heard somebody say that one. Now how do you find the slope?
9.
Yeah, so the slope will be y2 minus y1, x2 minus x1.
So 13,500 minus 9850.
If you do it that way, then you
Or
have to
other
do
way.
1 minus 3.
98.
Either way,
Yeah, the other way.
as long as you go the same direction on the top and the bottom. So if you want to do 13,500 minus 9850, on the bottom you have to be 1 minus 3. Or you do them both the other way.
Is there a better way to do it so it's like no negative humongous number, or?
No, the number is going to be the same. Period. Right? Because unfortunately every year it goes down by quite a lot. So what do you get here?
3650 over 4.
Yeah, let's see, 3650
1 minus 3 is negative 2, right?
over negative 2. So that'll be negative 1825. So what does that mean by itself? Like a negative 1825. What is this What are the units on the Y? What's the Y all about?
It's the
Every 3
depreciation,
years.
how much
Yeah, this is the money.
depreciated.
This is the year, so this is negative $1825 a year. So of course that's the, I
A
think
year.
you guys were saying it.
What do you mean,
Depreciation.
2 years?
Is that a year or 2 years? Because you have.
When we
the one and
reduce this, what's left on the bottom? When we reduce it, this divided by 2 is 1. On the bottom then is 1, is it not? Right? So let go of these numbers. We reduced it. So there's always going to be a 1 on the bottom of that whole number. Okay.
What if it doesn't come out to a 1 though? How would
It always will if I force it. I can make it decimals, whatever. If I come out to 0.072, that would still be per 1, whatever the hell it is I'm talking about, right? Per 1 year, per 1 second, per 1 person. Yeah. Cool. So it loses almost $2,000 a year in value. So how much? So that's part A. Part A would be find the equation of the line. In this case, that represents the depreciation of my car. So it makes sense it has a negative slope, right? Unfortunately, my car doesn't make money over time. That would be neat. And then part B would say something like, okay, what about 10 years after I bought it? How much value would it have? What can you do then? Oh, have I found the equation yet? That would probably be good. So now I've got everything I need for my equation. How do I put my equation together? So we picked our point. We got our slope. And again, this is a really good example of a part of math where if you're able to break it down into its parts, so you got a point, you find the slope from what they tell us, and now you just have to plug it all in the right place. Yeah.
So what I did was I times the 1825 times 10, because that's what it depreciates each year. And then, but that makes it 18.
Well, let's hold off.
Which is more than the
Part A would say
Yeah.
specifically find the equation of the line that represents this situation. So I've got to find this equation. And that's what's going to keep me straight as to exactly what to do with my numbers.
Okay.
If I find my equation, that's my rule.
So it's
So how do I fill this in?
So it's just
Y minus 13.
Yeah, the Y piece. M,
Negative 1825.
X minus
1.
1. Cool.
wait. So that's not okay. You don't use the y2. You just keep the y.
Yeah, this only needs 1 point and the slope. Now we did use 2 points. What did the 2 points get me? The slope, right? But for the equation, what do I need for a line? I just need 1 point and a direction. Therefore, there's an equation that exists that has 1 point and a direction.
What is that equation called? Is there a name for that thing?
Point, slope. Because this is the equation that has a point and the slope in it. Yeah.
But we used 13,500 as y2 when we did that equation. Does it matter that?
Does not matter, because again, it's completely arbitrary which one's called x1, y1. This really just represents the 1 point that you pick. Right? If I call this x1, y1 here, it isn't x1, y1 for the rest of its existence. It's just x1, y1 for that one thing I did to it. Cool? But if you want to keep it, whichever one you happen to call x1, y1, that will work, but you do not have to do that. For this equation, I just need to pick either point. It doesn't matter how I set up my slope. So how do I clean this up? Oh,
I have a question. So in this case, we use that equation because we don't have the y-intercept.
we don't have the y-intercept. I just have some general point. So I don't have a b,
Yeah.
but I do have an x1, y1. That's the distinction. Good.
So add 13.
Well, first off-
cancel it. Plus,
Distribute.
Yeah, distribute.
Distribute. Let me take this up here. You part B in a minute. So negative 1825x. What happens here? Good. Plus 1825. One last step.
Minus, or get rid of 13.
Yep. Add the 13,500. So y equals negative 1,825x plus 15,325. So may I have a way I could check that?
Okay.
Plug what? Where?
Plug the 15,325. No.
Plug this point in and see if it works. Why would I plug? See, I used that point to make that. Let me check it with the other point. Make sure this other point actually works in there. So somebody help me out. Let me make sure everybody's with me. Let me just stop right there for a second. So this is what we did last time. We did quite a few of these. We did some with perpendicular. We did some with 2 points and so forth. We find a point. They gave us 2, so I picked 1. We find the slope. They gave us 2 points, so I found the slope. Then we just plug them in the right place. Plug and chug. This is the part that feels like cheating almost, but once you get them, you just put them right in the right place, and then you clean it up. So now I want to check it. What should happen with this point, if that's the right equation?
It should get,
Yeah, when I plug a
with
3 in,
precision, so-
I should get 9850 out. Right? Do I? So let's check. If I check it,
times
y equals negative 1825 times 3 plus 15,325. $24.75. No. 75. $54.75 plus 15,325. Yeah, that sounds about right.
9850.
Good. So you get 9850. Sweet. Check. So I feel pretty good about them being the right line. I got it from this point. The other point actually checks in there. Does that make sense? I mean, that line, what's got to be true about that line? It's got to do what, considering what I was given? If it's the right line, it's got to go through both of these. So once I get a line, how do I check it to see if it looks like it's the right line? I plug a point in and see if it's true. When I plug a 3 in, I'm supposed to get 9850 out, and I did. Sweet. So that point works in it, thank God. That means that's the right line. So now how do I say, 10 years later, what's the value going to be? Yeah, put a 10 with the x's, and now I can finally catch up to your point. This comes out to negative, right?
Yeah.
Which is okay. Just means I'm over my head, underwater on my car.
I don't
Yeah.
understand why, as soon as you would find out that it just decreases by 1825 a year, you wouldn't just multiply it by 10 to get that.
If that was the only purpose in me doing this problem, you would be right. But this problem wanted the equation of the line that fit this, right?
Okay, so all of that is just to find the line.
Yep. Because now, if I have, let's say I find the equation of this line for a certain kind of car, driven in certain conditions or whatever. But then I have one equation. I don't have to give people all this crap here. I can just say, here's the equation that governs your car. You plug in whatever year you want. So then they can start there, right? So that's why it's good to get an equation that's true for some situation. You can use it and use it and use it, instead of having to start from the beginning every damn time. Yeah. Maybe.
So negative 2925, does that make sense?
Not really,
Because you
but that's
added
just, there's 2 points to this. One is that is kind of a steep amount per year, I think, but also, is it going to be a straight linear depression forever? No. So at some point it's going to kind of curve off a little bit. In fact, depreciation normally looks something like that. Right, if you've ever seen that curve before, it depreciates really quickly, and then it's like, oh, your car sucks already, so, you know. course, when you look at the whole board, you go, holy shit. But look at the parts of what's going on. That's points. I picked a point here. I found the slope there. We know how to find the slope between 2 points. The minute I have these two things, I throw them into the equation. Clean it up a little bit, and now I have an equation that's true for this car. It's true for this situation. I can use it to make predictions. You know, every time we do any mathematics, so this class is just for learning the basics. There's always a little more to real life. A lot of algebra is idealized, right? So when I drop a ball out the window, we can talk about how quickly it's going to fall. I don't want to bring into it air resistance and all this other crap until later, right? And then there's even other forces that might be slowing that thing down. I want to bring that in until later. I just want to talk about the basic, how does this kind of work? And then later we go, now let's bring in a little more complicated stuff about to make it more close to real life. This is not going to be a straight line forever. It's going to curve. But if I would have restricted it, doesn't it look like a straight line right there? So if I would have said it only works from 0 to 5 years. Very often that's what we do. So even if it's not a straight line, in some parts it looks like a straight line. So I could say here this straight line works and here this other straight line works. Because I'd rather work with a line equation than I would with squares or cubes or fourth power equations, right? Maybe. How much of that do you actually have to know for this class? Not much. Just what we did here. Right? Any other questions from homework that I can go way off on? Yep.
I have a question about on chapter 3-4, page 179. Number 15, part B. Like I get what I have to do, I just don't know how to do it.
Oh yeah. Alright. Alright.
Okay.
179.
It's actually on page 180, the elevator problem?
Yeah.
So number 15, yeah, at least a couple people had some trouble with this. Part A is not too bad. Let's kind of summarize what we know here. Laura entered the elevator at 2:38. At 2:40, she steps off. She's at the 34th floor. At 2:40, off at the 5th floor. So page 180. Find the rate of travel and number of floors per minute. And that's part A.
So I just did 34 minus 5, I got 29 floors
All right, so it goes 29 floors
in 2 minutes.
in 2 minutes. And somebody can argue about, this should be negative and it means it's going down.
Wait, is there a 13th floor? I'm just kidding.
Good point. Probably not. So there's a little trick to it, but math doesn't care about superstition. So yeah, we'll say this was invented, this building was created by a mathematician. So you people are all crazy. Just as many bad things happen on the 14th floor as on the 13th floor. And then you can take 29 divided by 2.
It's 14.5.
14 and a half floors per minute. Now the part B, now here's the thing about when they ask you the question, you write down exactly what they ask you. So part B says seconds per floor. Okay, I know how many floors I went. 29 floors. Do I know how many seconds it took me to do that? Yeah, 2 minutes,
Divided by 6.
not divided by, times 60. Yeah, right, because 60 seconds in every minute. So 2 minutes has 120
Yeah, that's what I did. Yeah.
seconds. I love it. Cool. Looks fine.
No.
Why?
No.
So 120 seconds.
Maybe I did do that.
Yep. Cool. And then when you divide that, you get like 4.3 1.4.
Yeah.
I didn't just do that, just to let you know that. Remember that from grading. 4.1 something seconds per floor. Sounds about right, right? When you're sitting there watching the number, it takes around that long, give or take, to switch from floor to floor. Right? Unless you're late for something and then it takes. The elevator knows you're late. Just like the yellow lights and the red lights know. This dude's late. Stop. I know that's exactly the way it works.
So like 1 minute times 60 seconds or 2?
So watch this. It's kind of
Oh,
cool.
2.
If I have 2 minutes, this is a really cool way to convert. 2 minutes.
Oh, yeah.
I want to go from minutes to seconds.
Yeah, put it to the bottom.
60 seconds and 1 minute. This says multiply. If it would have been down here, I would have divided.
Okay.
Why did I put the minutes down here?
Because they don't.
So they'll cancel. I don't want minutes anymore. I want seconds. It's a really cool way to set up conversions.
I was trying to think of that the other day because I learned that in my last class. And I couldn't.
Oh yeah. Another thing is when I go from big unit to small unit, I multiply. When I go from small to big, I divide. I don't know if you want to memorize that for some reason. See, if you're going to take chemistry, this will become this will be everyday occurrence, this kind of thing. You've already taken chemistry, you know exactly what I'm talking about. Any other questions from homework?
24 in that same section.
Oh yeah. These just sound like they should be difficult, I think.
Completes my homework.
How we doing with you? We doing? Take this out. 24 says at 4 p.m. it had traveled 400 miles and was cruising at a rate of 300 miles per hour. So at 4 p.m. Alright, so 4 p.m. it had gone 400, so I can just plot that point, no problem, right? So effectively what they're doing in this kind of problem is they're giving me a point and they're giving me a direction. So I should be able to draw the line. Give me a point, give me a direction, I got a line. So where am I going to go from this point here? See how this is y over x? See how that's a rate? That's a slope. 300 miles, that tells me to go up 100, 200, 300
I'm 1 to 5 to 5 o'clock.
over, understood 1, right? Up 300 over 1. That only makes sense. If I'm going 300 miles an hour later, I should be 300 miles further. So 400 plus 300, 700. That's really the math that's happening when we graph these things using slope. So we use this all the time. You travel to LA, you're going 80 miles an hour, you can figure out how long it's going to take you to get there, whatever. We do this kind of thing all the time. So there's mine, and I can go this direction if I really want to. I should probably be in there somewhere. Is that cool? So that's the line that represents this situation. Now, anytime I draw a straight line, I'm assuming that speed holds constant. And at some point, the damn thing's going to have to slow down. It does not want to land at that speed, I don't think. Is that all right? So there's several problems pretty much exactly like that. I think this problem gave some people a lot of trouble while I was grading the homework, I could tell. That's all you got to do. Graph that one point you know for sure. And then this tells you the slope. 300 miles, 1 hour. Okay. You guys don't want to let anything show. Oh. Guess how I feel, Jim.
We were supposed to turn this homework in already?
Which one is this? This is 3-4. No. That last test was up through 3-2.
I know you just said one of grading the homework, I see.
No. Some people have turned it in. Sure.
Oh, okay,
Yeah, you can turn in homework. The earlier, the better.
okay.
You know, as long as it's by the day of the test, that's fine. But the earlier, the better, because then you get it back with notes and stuff. Okay. So let's get into some new stuff here, or a little review first. Last time we got into 4-1. So let's try a 4-1 problem out before we get into what I was saying last time. So remember, 4-1 was all about solving systems graphically. So you graph a line, you graph another line, you see where they meet. They might meet at a really disgusting point. Negative 18.39, comma, square root of 2. I am not going to see that on my graph, especially not in my graph, as you can tell. So we're going to do one problem graphically, and then we're going to get into the algebraic ways of solving these things. Thank God it's an algebraic way, because algebra doesn't care how ugly the frickin' number is. It's going to kind of pop out at the end, right? So solve this system graphically? Let's see. Now I've got to make something that works. That's good. Good idea. Ooh, that's cool. Just to get you started, if you weren't here or if you cannot remember, graph that line on the exact same graph that line, and then see what you think. Bless you. What's up?
Is that negative stay there in front of the y?
Good. Because you subtracted 2x, so the minus y is still there. So you have to, and when you subtract
and then I have
2x,
to
it
take
should
it.
be
Now I
negative
got it.
2x there, right? And then you have to divide by negative 1, yep. What's the easiest way to graph a line? I like it.
What do you say?
Well, how can I get information? Is that me? No. How can I get information to know exactly where to put that straight line at? What's the easiest way to get one? Yes, solve for y, because what does that do? Puts it into mx plus b form. Then I know the slope, the y-intercept. Hopefully that's what most of you guys are doing. I would not necessarily find the x and y intercepts here. It's a little gross. So here, if I solve for y,
Y
you have to
equals
subtract 2x and then divide by negative 1. What I always do is if my y is negative,
Minus 3.
I add it and then subtract this mess over, so these just effectively switch places. If you don't like that, it's okay. Don't worry. If you like that, great. If you don't like it, it doesn't matter. Math don't care which way you do it. So here, if you do this, divide by -1, you get y equals 2x minus 3. That's the first equation. This was a little bit easier.
Y equals negative.
Subtract the x. So the second equation becomes y equals -x plus 3. We're going to force it in there, remember? mx plus b, the x wants to be first, so you just put that in. And 3 is positive, the x is negative. All right, how's that step by itself? Why the hell we do that? Why did we solve for y?
Then you can.
Because now I know, for example, I know for the first line, slope is 2, and the y-intercept is -3, right? So I can plot that pretty easy. So where's that -3 go? Yeah, down here. Yeah, now the slope tells me up 2 over 1, up 2 over 1, up 2 over 1. I always think more than, let's say, like 4 or 5 steps here. Go back in and really make these prominent. The reason I do that is because no matter how hard I try, I can't force myself to use a ruler. And without a ruler, I can't make a straight line. So if I just did that with 1 point, I would invariably go somewhere else. I would never be able to see exactly where it's supposed to be. So I force myself to do the slope to keep me artificially straight, right? That sounds like a late night ad. What about this guy? Yeah.
Wasn't that a negative 2x?
No, because we divided by -1.
Oh, okay.
Yep. So what about this guy? What do I know about him? The y-intercept is 0, 3, so it goes up here. And the slope tells me to go down 1, over 1, down 1, sweet. That saves me from myself. Because I know I'm not going to draw that line straight. So if I just follow that slope, I can see exactly when my other point right on top of that one, right? So what is the answer?
It's perpendicular. Oh.
2, 1, yes. Good.
Question.
That is a good question. What is the question? I mean, the question here is, what's the answer to this? And the answer has to be in the form of x comma 1. The answer to this is there's 2 variables. The answer must be a 2-part answer. Right? And every point has got 2 parts to it.
Oh, you divide
Yep.
-1 by
Once you just put them in that form and you see that it's a negative reciprocal, so you know it's perpendicular, is there a shortcut to just get the point to 1?
No.
There's not? You have to put them down.
2 things. This is definitely not perpendicular.
But isn't it? Oh, there's no 2.
Perpendicular is a specific way of intersecting. I can have 2 lines that intersect, but perpendicular means they're 90.
Okay.
Even if so, there's not a shortcut. Yeah.
So on 35 and 4, just making sure I'm not crazy, the answer is same line.
Where are we at? 35? Yeah. So, all right. Let me build up to this. How's that? Is that cool?
You didn't. Wait. So I'm just. The second one, you used this. You didn't use the same slope, right? You used -1
Definitely.
as your slope.
Definitely.
Okay.
This is a line in its own right. It gets
Right.
graphed according to what I
Okay.
see from it. This is a line in its own right. It gets graphed according to what I see in it. Cool. All right, so it feels like I want to give you one to do on your own. Here we go. You guys do this one, and then we'll get into the question you just asked, wherever that was. Oh, yeah, okay. So you guys do this one.
Now that make that one worse.
Well, Question?
So, do you always have to take, like, the -1, you divide it out on everything? But then
Here?
on,
Yeah. Yeah.
But then on the next one, you didn't.
I didn't have a -1 to divide.
Oh, only if it's
Y is positive. So to get this y by itself, when you subtract 2x, the y is still not by itself. So I had to do one more step to divide by -1. When I subtract the x here, is the y by itself? Yeah.
No, but I mean, do you have, like, see how you just divided the, oh, that's just over 1, never mind.
Yeah, I just put the over 1 when I went to graph it, just to make it look more like rise over run.
So anything with these ones, you have to do it to every single thing on the other side?
Yes. I mean, so if I have -1, -2x plus 3, if I divide one side by -1, I have to divide the other side by -1. But I want to break it up so I can still see my mx plus b. I have to get them separate. So that just becomes this. Because what's being divided by -1? This and this. Okay. So I just jump straight to divide each piece by whatever.
Okay.
Yeah. Put this over here. Okay, so solving this first one for y. Some of you guys might see what I mean. Add the y, subtract the 7. Much quicker way to get there. But if you subtract 4x, you divide by -1. Either way you do it, you're going to get here. Cool. And the second one to solve for y, I subtract x. So I get that, right? The -x gets shoved in there. Divide by 3. What's a better way to write this mess here? Yeah, -1/3, yeah. Just so you can see that fractional coefficient, so you can see what the slope really is.
It's not -3.
Definitely not -3. It's not being multiplied by 3. It's being divided by 3.
So it's -1/3.
Definitely, because what's in front of the x? Understood 1. Sure.
So, before you do any of the equation, you always have to have y equals something.
Before you graph it, you want to get the y equals something. Yeah. Right? I'm not sure. Is that what you're asking? Good. And again, I could have found what x and y intercept. I could have done this. I could have made an xy table. But we're past all that. The easiest way to graph most lines is to solve for y and see what the slope and y-intercept are. Because that's the quickest way to do it. So here's one equation. The second one is y equal -1/3, x plus 6. So now I just plot both of those equations.
My math class is so exciting.
Okay. So how do I graph this first guy? What do I know about him? Yeah, so the y-intercept is down 7 here. Yeah, up 4 over 1, so up 4 over 1, up 4 over 1, up 4 over 1. All right, John. Just make your points nice and easy. Okay. And then this guy, what do I know him? Yeah, the 6, place to start, this is the y-intercept. And the slope tells me to go down 1 over 3. Bam. Down 1 over, I'm there, so who cares? Is that cool? Yeah, this runs 3, so it goes over really quickly. The other one took forever because it only ran 1. Yeah, so the answer is going to be 3, 5. I love it. And how do you check that answer? Yeah, plug it in. Plug it 4 times 3 is 12 minus 7 is 5. Check. Negative 1/3 times 3 is negative 1. The 3's cancel. Plus 6 is 5. Check. Right? If that's going to be the answer, it's got to work in both equations.
Emerson, I don't know where you get 3, 5 at. Yeah, one-
That point, what's the coordinates of that point? 3, 5. That's it? Yeah. Once you graph that line, don't just circle it and say, there it is. You got to tell me the answer is 3, 5. Yeah. Cool. Say again? Yeah, just like that's good. Right. Don't just not write that and say, there. You have to give me the answer. Yeah. Cool. So how do you feel about that? I mean, obviously, if you have trouble graphing lines, this will be a problem. But if you're pretty decent at graphing lines, you just have to graph 2 of them. Count a little further on your slope than you normally have to, just so you can make sure you see where the points actually overlap. Okay. Cool. So, especially if you don't like to graph, I might not need to give you a lot of motivation as to why it's good to have an algebraic way to do these kind of problems, right? But, I mean, imagine I can give you 80x minus 11.2y equals 13.98. I am not going to graph that. Screw that, right? I am not going to graph that. Yeah?
So, for the y equals 4x minus 1, when it's a whole number with the x, you gotta go over 4?
No. Any whole number is understood to be over 1.
Okay, so you're not going.
So then it's rise 4, run 1.
Okay.
Yeah, the whole number part will be the top always. So that whole number part would be the rise. So anytime I have a whole number slope, it's going to always run 1. It's going to rise or fall, whatever the hell that number is. So that's going to be on the top. Cool. Yeah.
Are there ever going to be, there ever going to be a chance of there being a perpendicular parallel?
No. But the before I forget now, before I get into the algebraic, what could happen? I mean, I could graph 2 lines and they could meet in one place, and there's my answer, right? Whatever the hell it is. What else could happen with 2 lines? Do they have to meet?
Parallel.
They could be parallel. In which case, what's the answer? No solution. No level. There's a third thing that could happen.
Same one.
Neither.
They could be the same line. So there could be no answer, one answer. And remember, the answer is always the point or points where the lines meet. So if I actually have the same line, and normally they do it like this, y equals x plus 1, 2y equals 2x plus 2. Are those different equations? No, this is just double that one, right? So it's the exact same situation as me saying I'm twice as old as you and you're half as old as me. Figure out how old we are. You're like, I can't do that shit. You gave me the same thing twice over. So when I graph this, that's the first one. When I graph the second one, it's going to be right on top of it. So if the answer is every point where the lines meet, what would the answer be? No, not the number of answers. What's the answer?
All same one.
Tell me, what's the answer for this for system equations got to look like? It's got to be a point. So don't tell me all real numbers that didn't make a damn bit of sense.
Negative infinity to positive infinity?
Nope.
It's just going to be a slope, isn't it?
What points do these meet at?
Everyone.
They meet at every point.
On that line.
There it is. There's the answer. All points. Coming strong at the chorus. I like all points on the line y equals x plus 1. The answer is always where the lines meet. If they actually are the same line, they meet at every point on that line. All points on the line are the answer. The idea never changes. The answer is always the point or points where they meet. So if they meet at every point in the line, that's the answer. Every point on the line, period. Now, this is called dependent, this is called consistent, this is called inconsistent. I don't really care that much about the names. I just care about if you can do it and give me the answer. Right? I like it. Okay, maybe. So that's like the number 30. Which one was it? 35? 35, it ends up being pretty much exactly the same situation. One is double the other one, so when you graph them, they come out right on top of each other, so that your answer would be all the points on that line. So could somebody, without graphing, tell me what the answer is to this? Yeah, the parallel, so no solution. I love it. I know that they have the same slope. I haven't solved for y yet, but once I do, I really didn't have to. All I care about is the fact that these two numbers are not the same. Everything else is the same. So it's going to have the same slope, different y-intercepts. Therefore, parallel, no solution. There's no solution.
No solution because it's asking for the points that they meet at, you're saying.
Exactly. So the solution to a system of equations is the point where the graphs would meet. If the graphs never meet, there is no solution. Right? Yeah.
When do you start subtracting one against the other?
Oh, that's where we're getting. Don't worry, we're getting there eventually. Yeah. Like enough of this graphing, Jeff. But real quick, a real life application would be. The bad guys have the bomb, and this is me overhead looking, and they're going to make it here, and I'm like, oh crap, how fast do I have to go so I can catch them? And you do the work, and it comes out to be parallel lines. What that means is you can't catch them. They're going to get too bad for you. Do you have the James Bond car? Can you hit the turbo? No? Oh, we're all dead, thanks. There's real life applications as to why math gives us something that there's no answer. Math didn't give us this. We gave math this, and it says there's no answer. There's no way that those could be agreement. That's why it's called inconsistent. They're not consistent with each other. They don't agree ever. Okay. So let's get into the algebraic methods.
Which section is this?
This is starting at 4.2. Oh, wow. Not the best thing in the world, is it? 4.2 talks about the idea of substitution. So, it's going to come up with a physical situation. Let's just jump to the math. If I give you these equations, let's just say, if I give you these two equations, we could graph them and solve, and it's not that bad. But there's an algebraic way to do this, and there's two algebraic ways to do it. We're going to start with the substitution method. There's also one called elimination method, which I personally prefer. But substitution method is very good too. I mean, what does the first thing actually tell me? I don't know what the hell x and y are, but I do know that x is 2y plus 3, right? I know that. The first equation tells me that is true for this situation, right? Cool. You're all like, yes, Jeff, that's what that damn thing says. But I really want to make that point, because when I come to this equation and I start reading it, twice x. Wait a minute. I know what x is. So let me replace x with what it is. So twice x, which is twice 2y plus 3. That's why it's called substitution method. You guys with me?
Is this like a whole different thing from what we were just doing?
It's the exact same thing. We're just solving it a different way.
Like, is that supposed to be like the y equals mx plus b?
Not supposed to be. It's just an equation somebody gave me. Now, if I wanted to graph it, I would put it into y equals mx plus b form, right?
Okay, so I don't want to like.
You with me?
I was thinking I have to like get that y over there.
No, definitely not. So twice x, where x is this, minus 5y. Now, what good did that do me?
Got rid of your x's so you can solve
Yeah,
for y.
it's a very subtle way to get rid of my x. The whole problem with either one of these is there's too many freaking variables in each one, right? I can't solve either one, man. Solve for x and I got some y on the other side. I can't get a number. Well, if I replace one of the variables with something to do with that variable, the only variable I have in this thing is y now. I can solve that for y. I can get a number for y. Kick ass.
4y plus 6. Negative y.
Negative y.
And subtract 6.
Subtract 6. Negative y equals negative 1. So y is 1. Now don't just circle that and keep going.
You plug it in.
Good.
So x equals 5, and then
I like it. So remember, your answer to any system of equations has got to be a point. It's got to consist of two parts.
and then you plug it into 2, it's 5 equals 5, so then
Sweet. So once I get one variable, I can plug it back in. I can plug it back into either one of these, but of course I'm going to plug it into this dude.
you find out what x is.
Because x is that. It's already kind of solved for, right? So I know y is 1, so I can rewrite this as x is twice 1 plus 3, so x is 5. Cool. And then to check it,
10 minus 5
you plug a 5 in, you plug a 1 in, and sure enough, 10 minus 5 is 5. Check. You can always check it by plugging it into the other one. Yeah.
What do we do for a variable? We just solve for the equation, that's all.
I know the answer now. What's the answer?
5
I love it.
point,
5, 1.
and then
The answer to a system of equations is always the point where they would meet if you graph them. I did not graph them, did I?
no.
Hell no. I did all the work algebraically, but I don't care. That 0.51 is where these two would meet if I did graph them. How we doing? Yeah.
This is just known as intersect?
This is substitution method. So there's two algebraic methods. One of them is called the substitution method. And it's very appropriately named because it just substitutes one variable for this expression here.
But what does that 0.51? What is that 0.51?
Those lines where they meet.
That's where those two lines meet.
Exactly.
If you would solve for it and did all that, subtracted that.
Only, yeah. So if I did graph these, they would meet at the 0.51. Another way to say this is that 0.51, that x and that y is what works in both. That's the only point that works in both. Cool.
So
Yeah.
you got rid of the x because
Because I know from the first one, x is this. So then I can replace x with that. And that's why it's called substitution method. Right? Normally, we replace a variable with a number. And that's cool when we know that. Here, I don't know what the hell the number is, but I do know another name for x. It's also known as 2y plus 3.
But you put the 2 right there because it's 2x on number 2.
So I'm just going to have 2 times x. So 2 times x. So anytime I substitute something in, I really should put it in parentheses to maintain what's going on. Good. Let's try another one. Oh, let's see. Let's make this more interesting. She's trying to avoid the exceptionally ugly answers for right now. Yeah, it's a 3-1. So what's different about that set than this set? X was by itself already, so okay. Which variable do you want to solve for?
Y.
I would never solve for any of these. Do you understand why? If I did try to solve for them, wouldn't it bring in a bunch of fractions?
Yeah.
Right? If I had to, I should be able to do it, but if I don't need to, hell no. I'm not going to make myself make mistakes. So I definitely want to, if I have to do substitution method, I'm going to find a variable that has a 1 coefficient, if there is any, and solve for it. So if I take the first equation and I solve for y, how do I do that? Yeah, minus 2x. Now I know y is negative 2x. And then, what can I do with number 2? Substitute. So 4x minus 3 times y, but y is negative 2x. So see, I'm writing 4x minus 3y minus 3y is negative 5. So I write the equation exactly as it is. I don't leave anything out. I just replace one variable with whatever I solve for it. Right? So I know that y is negative 2x. So when I go to write this, why write y? Why not write what it really is? It's negative 2x. I use information from this guy to help me in this guy. And that feels very real life. If somebody gives me some information, I can use it. Right? Like, I know this guy uses his name for the password, but I keep putting his name. He's also known as Fat Tony. Okay, Fat Tony. There you go. Yay. That's an example of a stupid example of substitution. I substitute his nickname for the name I know him by, and it worked. Yeah, I'm in the door and doing whatever the hell I want to do there. Same thing here. I don't want to use y here because that sucks. If I can replace it with something better, I just did. And it's better because it's the same variable as what's in there already. So how do I solve this?
Or distribute the negative.
Yeah, negative 3 times negative 2 plus 6x. Some of you guys might see how nice I was on this one. Yeah, buddy. Divide by 10. X is negative 1/2. Hold the John. Are you guys with me on that? A lot of people see this and the brain just says 2. But be careful, you got to do the steps and show your brain, no brain, it's negative 1/2. And like John said, you can now plug this back in. Now I have information about what x is. I can use that here. Y equals negative 2 times x. What's negative 2 times negative 1/2? Negatives cancels. The 2's cancel. 1. Positive 1, that's better. So what's the answer? 1 and 1/2. 1. I like it.
Is there a reason I'm just confused when you go from plugging that negative 1/2 back in, can you just go over that? Like,
Which equation do you choose?
Is that the question?
Which original equation did
I could use either one I want to.
Okay.
I am certainly going to use the easier one, which is always the one that's already solved for the other variable, right? But now watch, if I chose number 2 instead, 4x minus 3y equals negative 5, I know x is negative 1/2, right? So this will become, negative 2 minus 3y is negative 5. Add 2, negative 3y equals negative 3, divide by negative 3, good Lord. Y is 1. I get the same damn answer. Why am I guaranteed? That's a good check. Because what's supposed to be true? What's this point all about? It's the point where these two meet, where these two are equal to each other, where they agree. That's why it doesn't matter which one I pick.
I think I just got confused because you put it back into the simplified form instead of the top.
This equation is the same as that equation.
Okay.
Yeah. Yeah, you can plug it back into the original if you want to, but I'm always going to plug it back into the simplified. Make it quicker. Yeah. Are you guys with me? Is that right? I mean, once I know one letter, I can plug it back in and know the other one. So, the whole point here is, if I write down here, x plus 2y equals 7. What's the answer? Okay, this is good. This is the appropriate responses. I don't know. But if I told you, okay, x is 5, okay, now, I would plug it in. Doesn't matter where that came from. In this case, that came from me. I just told you directly. X is 5. Over here, we figured it out. We figured out what x has to be. Given that this relationship has to be true, we plugged it in and figured out what x had to be. The minute I know that, I can plug it back in to see what y is. Just the same way you would automatically do this. There's too many freaking variables. Well, if I tell you one of them, you can solve for the other one. You know that. So this is just, nobody told me x was negative 1/2. I had to use this information to figure out that x was negative 1/2. But the minute I know it, I can plug it back in. Either one, because they're both going to come out to the same answer. I love the look on some faces.
Monday.
I understand. We do one more of these with you. You'll see how ugly they get here in the book. That's the one. Yeah, this is good. Oh, that's really okay. Oh yeah. So the instructions say you have to do substitution. So if you've taken some math before and you know some other way to do it, that's really nice. But when you're doing this section's homework, you got to do substitution. So what's a good first step here? Yeah, good. So keep going. No, don't say it out loud. Keep going. Solve for x. Get x by itself. If you know what x equals, I can put it in. Yeah. You gotta be careful here. -28 equals 28. It wouldn't be 0 to 0. Even if you got that, what would the answer be? But you don't get this. Is that ever true?
No.
So, what? Mm-hmm. Just make sure we all got the right first step. I have the 3y over. Can't use the substitution method unless you have an equation with the variable by itself. Because then I know x is this. So I can plug that in place of x.
You get negative 12 plus 12. Negative 12y plus 12y.
Oh, right here. So you can negative 4x.
So, and then the y goes away, right?
Huh?
The y just goes away.
Mm-hmm.
Replacing x with what you know it is. You left out part of it. That's a common mistake, so.
Yeah.
Yeah, you have to rewrite this equation, replacing x with what it is. Everything here's got to show up here. Yep. Yeah, I'm not sure why it says negative 28. Yep. Looks good. There you go. Yep, it's gonna go away, but we don't.
Is that not a negative 28?
No, that looks good.
Oh.
Now, what does that mean? So, the most common mistake, I'm not picking on anybody, but the most common mistake is to write this. What did they do wrong? Yeah, so I have to rewrite. So I wrote negative 4x, there's negative 4x, plus 12y equals 28. But that happens all the time because it feels like you've written enough. Well, no, you haven't. You got to write the whole equation there, or else it's not true. Now, a lot of you guys did everything correct. I was kind of walking by. A lot of you guys all were staring at the same spot. When you multiply this in, and I'm not saying there's nothing wrong with that. It's just the way it is sometimes. We're not worried about our variable canceling. We don't care. Hell, that's great. Go away. Because then it's an easy answer. So these go away.
So it's just negative 28.
So negative 28 equals 28. Is that true ever?
No.
So what's the answer? No, what's the answer? I'm done with my work. I've gotten to a point where it's never true. So is it ever true? No. They're never true at the same time. No solution, which means what physically? These lines never touch. They're parallel.
So if it was like 28 equals 28, that would be all.
Then it would be all points on the line. If I would have gotten 28 equals 28, it would have been all points on the line.
So would you like parallel line or no solution?
Parallel lines is not
Always true.
the answer. It's the situation, but it's not the answer. The answer is no solution. Cool. Yeah.
So they come out parallel because the negative 28 is the opposite of the positive 28.
Yeah, that's why they're not right on top of each other. Okay.
But if it was like 0 or 28 equals 28, it would be the same one, right?
Same line, so the answer would be all points on that line. Good. Some of you guys might remember I had a negative there first because I thought that's what they were going with, and then there wasn't. Like, oh, we're going the other way. Cool. Real quick, look at number 2. What can you divide by? 4. Negative 4 even, right? If I divide by negative 4, what do I get here? X minus 3y, negative 7. X minus 3y equals 7. X minus 3 equals negative 7. Parallel lines, different y-intercepts, so they're parallel for sure. They're not right on top of each other because they are offset by their y-intercepts being different. You guys see that? So anytime you can divide, I would do that. Because I would completely take, I can tell that they're parallel, Jeff, no solution. That's awesome. The more you understand, the less work you should have to do. Right? Yeah, you're good.
So would you write you wouldn't write a cross thing because there isn't one. You wouldn't write like negative 28 comma 28.
Oh, hell
It's not a cross.
yeah.
That's only for crosses.
Yeah. I mean, I don't have y equals anything. So I don't have any y piece of a point. Because actually this tells me there is no point where they meet. There is no solution. My y's went away. That's trying to tell me there is no y piece that you seek. There's no point that does what you want it to do. Okay, hopeful. But I desperately want, when that kind of thing happens, I can understand some of us getting a little freaked out, especially if it's been a little while since we saw one of these. Like in a roll, x equals 2, plug it in, y equals 5, yay. And then you come up to this, you're like, Whoa, what the hell? But remember, when your variables want to leave, when they cancel, let them cancel. Don't try to hold on to them. That's a special case. It's an easy answer then. You have less work to do. No solution here. If it would have been 28 equals 28, all points in the line. You're done. Quick. Let them go away if they want to. I'm going to have people making them go away when they're not supposed to. No. Okay. All right. Maybe we could do one more of those and then take a break. Yeah? Let's see. It's the same thing, solve by substitution. Yep.
But once you get A, you can plug in to get B. And once you get A and B, you can plug it into the other equation and check it.
What I did, I solved for these, then I plugged it in on the first problem. So I did negative 2a plus b, and I subtract 2a, but that can be b by itself. So it would be equals negative 2a plus b.
Okay, so what's the